Okay, guys, so I thought it might be helpful for me to work out some of these review problems. After you check your answers, if you're still having problems, you can hopefully come here, see how I'm doing it, hear me talk through it, and that'll help you out. Okay? So for numbers 3, 4, 5, and 6, what you want to do first is decide what type of series it is that you're trying to sum up. Remember, with an arithmetic series, we're looking for a linear sequence. Does it look like mx plus b? For a geometric, we're basically looking for something exponential. Is it something to a power where your variable is the power? If it's neither of those, then it would be a neither. So if it's arithmetic or geometric, we get to use a formula. N over 2, a1 plus an. Geometric is a1, 1 minus r to the n, divided by 1 minus r. If it's a neither, then we're just going to have to write out all the terms and add them up ourselves. Okay, so let's pick that out first. Number 3, if you look, there's an exponent. Automatically, an exponent rules out anything arithmetic. Because the exponent is a variable or is not a variable, I know it's not geometric. So this sequence is a neither, which means I'm going to have to go ahead and find the terms and add them up. Remember, to find the first term, we plug in that bottom number. So putting 0 in for my, not for my power, putting 0 in for j means my first term is 0 squared plus 1, which is 1. Second term, 1 squared plus 1 creates 2. 2 squared plus 1 is 5. 3 squared plus 1 is 10. And I know 4 is the last number I'll plug in. So 4 squared plus 1 makes 17. And now we just need to add those up. So 1 plus 2 plus 5 plus 10 plus 17 gives me a total of 35. So the sum for this series, 35. Now number 4, again, we need to check, is this arithmetic, geometric, or neither? Do you see how it's arithmetic? We've got the linear expression there, mx plus b. So we're going to use our arithmetic formula for that. Now for arithmetic formula, we need to know what n is. N is going from 1 to 11, so that gives me 11 terms. Okay, so 11 over 2. I need to know the first term in the series. That's what I get by plugging in 1. So 2/3 times 1 plus 4, which is 4 2/3, which is 14/3. And the last term, plugging in 11, 2/3 times 11 plus 4. I'm going to cheat. What am I doing? 2/3 times, not 11, not 4. 11 plus 4. 11 and 1/3 is 34/3. So 14/3 plus 34/3. Okay, so now I'm ready for the sum. So let's do, I'm going to scoot it over so we can see. 11 halves times 14/3 plus 34/3. And my sum is 88. Okay? Okay, number 5, back to a decision. First off, is it linear? No, because there's an exponent. And is that exponent a variable? Yes. So I can say this is a geometric sequence or series. Now, I only wrote one formula for geometric, but hopefully remember there actually are 2 possibilities. So, next decision, is this finite or infinite? Do you have an ending value? We sure do because of the 4. So I know this is a finite series. I'm going to use the formula I wrote up there. Okay, I need to know A1. A1 is determined by plugging in the bottom value. I know anything to the 0 power is 1. 250 times that is 250. So 250 is A1. Okay, 1 minus R is always inside your parentheses, so 1.02. And N is our number of terms. Now, if we're going from 0 to 4, that actually is 5 terms. Count them up. 0, 1, 2, 3, 4. That's 5. Okay? 1 minus R gives me 1 minus 1.02 on the bottom, and we're ready to plug into the calculator. So 250, 1 minus 1.02 to the 5th, divided by 1 minus 1.02. And the sum of that series is approximately 1301.01. So 1301.01. Okay, so now for the last one. Again, decision. Arithmetic? No, there's an exponent. Is it geometric? Yes, the exponent is a variable. Is it finite or infinite? This one is a finite. Oh, infinite. That would be an infinity sign. So this one is infinite. Our infinite formula is just simply a1 over 1 minus r. Now remember, we can only use this formula if r is less than 1. Is r less than 1? It is. So this one will have a sum. If r is more than 1, we would just simply stop and say no sum. Okay, so I need to know first term. What happens when I plug in 1? I get 1/3 to the 0 power, which is just 1. Denominator, 1 minus r. So 1 minus 1/3. That gives me 1 over 2/3. I'm going to flip and multiply. So 1 times 3 halves gives me 3 halves as my sum. Okay? Okay, so last but not least, writing in sigma notation. Is this arithmetic or geometric? I don't think so. I don't think I'm adding the same thing each time. I don't think I'm multiplying by the same thing each time. So this one's a neither. So we just need to identify a pattern. If you look at all the numerators, they're all increasing by 1. I'm going to call that n. Remember, when I write in sigma notation, the numbers I plug in increase by 1. So there's our n. Now for denominator. How does the top relate to each of the bottoms? It looks like the bottom is always 1 more than that. So let's put n plus 1. Okay? First number to plug in is 1. Last number to plug in is 11. And we've got our sigma notation.